Assalamualaikum, my name is Nur Shakila binti Mazmin. Today, me and my group members from Section 2 Group 5 will do a video demonstration for Lab 2 on-off and proportional integral derivative PID controller. Assalamualaikum, my name is Nur Shakila binti Mazmin. So I will do a demonstration for on-off controller. So first, for the desired temperature, we set the set point equal to 85. And then for the on-off controller, we set to the switch on point 3 and switch off point -3. And then we run the simulation. So just wait until it finishes the compilation. We double click at the scope. So you can see here, since we set the neutral zone is 3 to -3, we can see the upper band is 85 plus 3 is equal to 88. And then the lower band is 85 minus 3 is 82. So here is the result for the upper and here is the result for the lower. So next we proceed to when we change the new neutral zones value, we set to 1 to -1. And then we run the simulation. So we can see here the neutral zones for we change. Since we changed, so the upper band is equal to 86 since 85 plus 1, and the lower is equal to 84 because 85 minus 1 is equal to 84. And then we try set the new neutral zones again, which is 6 to -6. So we can see the result. So you can see the result here. Since we changed it to the new neutral zones, the upper and lower bands values we change also. So since we set 6 to -6, 85 plus 6 is equal to 91 and 85 minus 6 is equal to 79. So I will continue this presentation for the part A for the P controller simulation. So here is the P controller simulation. So first we set the set point, temperature set point equal to 60. And then for the time delay 150. And then for the initial temperature we set to 28. And for the integral gain we set to equal to 0. And for the derivative gain we set equal to 0. And we only change for the proportional gain. So first we set the proportional gain equal to 0.0024. So we run the simulation. Okay, wait. So after the simulation is successfully run, we open the scope. So you can see here, when we set the proportional gain equal to 0.04. So next we set the next procedure, we need to set the proportional gain equal to 0.009. So we change here 0.0009, and then with 0.0009. So we run again. So here is the result when we change the proportional gain equal to 0.0009. And then for the next step, we change the proportional gain equal to 0.005. So again, we change to 0.005. Okay. So we can see here the graph is become more better than before. So as we can see from the result, when the proportional gain is increased, the graph is become more better. So that's all from me. Thank you.
Assalamualaikum, my name is Muhammad Shukri bin Nasrullah and my matrix number is DE190126. So for my part, I will explain for the lab 5.32. So this is the circuit that I have made. So firstly, we go to the list. I have changed the value to 0.00216, and second one is 0.0000432. Then lastly, the gain is 0. Then this is for the upper limit is 0.02, and the time delay is 150, and the temperature is 28. So I run this circuit, then for the oscilloscope you can get the graph like this. Next, I change the KI value to the 0.0000632 as the instruction. So I run, then for the scope we got this graph. And lastly, for the KI value, I have changed to 0.0000222. So I run, and the graph is like this. That's all from me. Thank you.
Hello and Assalamualaikum. My name is Nasuha, and today I'm going to be presenting for Lab 2. My part for Lab 2 is Part D as well as the conclusion. For Part D, I have to tune or adjust the proportional gain or integral gain and derivative gain so that I can have 2% band settling time at the value of 2700 seconds or below, as well as I have to have the percentage of the shoot is 30% or less than 30%. Okay, so here are the systems that I have created, and I have already adjusted the gain, which I will put the value at the report, but here are the proportional gain, and okay, here is the integral gain, and here are the derivative gain. Okay, so I'll just set it like that. So if you look at this code, here. So the resultant graph will be like this. And for the calculations, I will be calculate it beforehand. Okay. Here is the resultant graph, and for the calculation, they want 2% band certain time, right? So how do we get 2% band is that first we have to take the C minimum and C transients, which is for the C minimum is 28 Celsius and C transition is 60 Celsius. And then in order to get 2% band, we have to minus the C transition with the C minimum, and then we're going to multiply by plus minus 2%, and then the result will be added or minus to the C transition. And here are the certain time, and here are the 2% band that we have to get at the certain time. Okay, so as you can see here, those two results will be present here. So I already put the time here. For 60.64 Celsius, it is at time 2607.143 seconds, and for 59.36 Celsius, it is at 2659.524 seconds, which both value are less than 2700 seconds. For the percentages we should, the formula is Cmax minus C transients divided by C transients and then multiplied by 100%. Using the value that we have obtained here, we can gain the percentage overshoot is 28.267, which is lesser than 30%, which is according to the questions. Okay, so for the conclusions, from this experiment, we are able to see and understand the basic characteristic as well as the concept of on and off PID controller, which in this case acts as a temperature control device for the heating process. In this experiment, we can see that the output switch every time it hits the temperature set point. Next, we also are able to see how PID controller works. PID controller combines proportional control with integral and derivative control PID, where we have to manually adjust the triggers in order to get the desired system. This is the second sentence relates to what I just done earlier. Okay, so that is all from me. Thank you.